Does have any questions before we get crack-a-lacking and finish her off? Well, let's do the darn thing here. I think about 30 to 45 minutes worth of stuff to kind of get through today. That'll close out chapter 15. Next class, we'll do the review day and the half sheet. The following class, we're going to, in the interest of IB testing, not do our chapter 15 test. We'll just do like a regular lesson, and then your test will be Wednesday next week, which seemed to be more agreeable than Monday. Yeah, I mean, it's... We'll figure it out.
I guess we get done at 12:15.
We'll figure it out. Who's we? Okay.
So you two.
No, not me. I'm IB testing.
Not me.
Okay.
I didn't see you.
So I'll IB testing Wednesday and Thursday.
All right, we'll figure it out. We'll talk again on the review day.
And then I have a test on my AP Computer Science the 23rd.
Okay.
But I think that might be.
Yeah.
Well, it doesn't. But I don't know if I have it now.
Yeah, little bit matters.
Because
Okay.
they have it next week, but it interfered with my IB testing, so they just moved it back.
Gotcha.
So I have an AP test this Friday, 2 parts for that. For all of it sucks.
When is that? Andrew,
AP
it's Friday, then when's the IB?
next Wednesday and Thursday. But it's 2 hours and then an hour and 15 minutes. So the AP test like 3 hours.
All right. So we'll talk more then the review day and figure out what to do. Maybe it'll be like have 2 days that you can try to do the test in or whatever, and maybe we'll just do that or something. We'll figure it out. Sound good?
Yes.
Fair enough? Yeah, all right. I'll make it worse. Let's get this finished up, right? So at this point, last time we talked about simple interest and compound interest, and now we're going to talk today, or start talking today about, one of the things we'll talk about today is continuously compounding interest. So if I say we're going to, like we have continuously compounding interest for 1 year, how many times is that interest going to compound in 1 year? If it's compounding continuously. How many times? What do you think? Somebody take a guess. More than that. Infinite number of times, right? If we're compounding continuously, at each instant, interest is compounding and some fractional percent of that annual interest is being paid at every instant. As a result, on our compound interest formula, turns into this guy with the E in it. So we have FV is equal to PV times E to the Rn over 100. Notice the Rn over 100 is the exponent. Yeah, go ahead, homie. So again, FV is still future value, PV is still present value. E is that number, that 2.71 irrational number we've talked about a few sections back on. R is the interest rate as a percentage. N is the number of years. Let's do an example. Jack invests $800 into a savings account with a 5% annual interest compounded continuously. How long will it take for Jack to have $500 in interest? How do I know which formula I need to use? What word in the story problem tells me what formula I need to be using? Continuously tells us we're going to be using this formula. Okay, what is the 800? Yeah, that's the PV, present value, or principal value, either. The 5% is the R, yep. How long, so what are we solving for? Well, that's n, the number of years. And then, well, we'd have to have, what's the future value then?
500.
No.
Oh, it's 500.
Yes. So it says we have $500 in interest, which means we've picked up $500 on the $800 that we invested. So the future value should be $1,300. Very good. So the equation we need to solve for then is 1,300 equals 1,800 times e to the 5n over 100. What's one way that we could solve this equation? What's one way that we could solve that equation? I mean, you could do it algebraically, but what else can you do? Graph and find the intersection, right? Let's do that. So I'm going to type into the left-hand side, or type the left-hand side into y1, and then the right-hand side into y2. Yuck. You stay over there. That look okay to everybody? Just want to point out to you, since most of you guys are juniors sitting in the room, if you're planning on taking an ACT test this summer, this technique we're doing of solving the equation by graphing and finding the intersection will work for any solving problem. So if you're taking an ACT test where it's multiple choice and nobody cares about your work, that would be my preferred method of solving because it eliminates all of the algebra computational mistakes that I might make along the way. All I got to do is get into my calculator and get the answer out of it, and that's a good deal for me. Because on a 60-question ACT math, how many of them do you think are probably like solve for X problems? Probably 15 or so, like a quarter of the questions are probably something that, like, if I know what to do, I can just type this thing in my calculator and press enter. Yes, sir. Thank you. All right. Let's set our window for this. So the X here is the number of years. So I know that minimum has to be 0. We can't have negative time. How long will it take to earn $500 in interest? I don't really know, but it's going to take a while. I mean, probably at least 10 years. I always kind of double up whatever I think the answer-ish might be because I'd rather be too heavy than too light. Because as long as I can see the intersection, my calculator will be able to find it, so that's not a big deal. The Y's are the values. The least amount of money that account is ever going to be worth is the $800 I start with. The most that it needs to be worth, well, it has to be bigger than $1,300. I'm going to just do like $2,000 and just kind of do a nice round number there. And let's hit graph. There's my 1,300 line. Here's my account value. There's my intersection there right in the middle. That's lovely. Second calc, or second trace, intersect command, enter, enter, enter. So n is about 9.71 years. Could also solve this equation with a logarithm if you'd like. Divide by 800, do the natural log of both sides, and then multiply by 100 over 5. But this works nicely too. I think that's mostly what we've been doing is graphing and finding the intersection, right? It is doable algebraically, but like this is a nice technique. It's about time we spend some time practicing doing it. It's a pretty helpful one, especially come standardized test time. Next example, you find an account that has a 6.5 annual interest rate compounded monthly, and we want to know what would the equivalent interest rate for an account that's compounded annually. All right, well, let's think about this for a minute. So if I have this 6.5 compounded monthly, I'd have something like this, right? And then I want to find an account that's, or an interest rate that's equivalent, but instead of compounding monthly, it's compounding annually. So the K is 1. if I look at this now and compare the two equations that I've written, those parts are exactly the same, right? So if I want these two interest rates to be equivalent, this needs to be equal to that, right? Again, you could graph this and find the intersection, but like, look at this thing on the right. It's to the first power. The parenthesis doesn't really need to be there. To get the r by itself, it's got to subtract 1 and multiply by 100. Let's do that. Bless you. You're welcome. Everybody agree? So I'll just stick that into my calculator. Move it over here so I can see what I wrote down. Again, if you wanted to, again, you could graph that and find the intersection. It just looked to me like it's going to be more maybe work than it was worth it. Mostly because, oh, boysies. Come on now. Way to go, Kulik. So about 6.70. Now, why would we be interested in doing something like this? It's actually a fairly common consumer question. If you have two investment opportunities, how would I be able to tell which one's better when one is a different interest rate compounded differently than the other one? Well, I could convert each of those situations into annual interest rate and just see which one is better, right? And in fact, that's what we mean by an APY. So I think there's a consumer law that says that all of your loan offers need to be given to you as APYs, even if that's not actually how the loan is the terms of loan are actually stated. Like the interest might be monthly, monthly compounded or whatever, and a different interest rate, but they're going to give you an APY. And the reason that I think the consumer laws dictate they have to give you that is just to try to make life easier on you as a consumer, right? Because if you are asked Joe Schmo consumer that maybe didn't even graduate from high school to figure out which loan is the better one for him, and you're giving he's getting stuff that's different interest rates, some are compounded annually, some are monthly, some are weekly, some are continuously. How the heck is that person supposed to figure this out? So that's what this is. This APY is just saying whatever the terms of the loan, we're going to convert that into annual interest or an equivalent percentage annual interest. So it makes it easy to compare two different, investment opportunities or loan options. For an investment, do you want bigger interest rate or smaller interest rate? Bigger, because you want to make more money. If it's a loan, which one do you want? Smaller, because you want to pay less money, right? All right. So the example here says which savings account is the better investment, one that pays 7.8% compounded quarterly or 7.65 compounded weekly. So again, nothing sneaky going on here. Right, just the usual. Just doing some plugging and chugging here, right? So I have 803 for the first percentage. And 794 for the second. Which one would we like better? The bigger one, because these are investments, right? Pretty easy, right? Again, whenever you're comparing two loan or investment opportunities, this is really what you're doing. You're just calculating the APYs and picking the better one, whichever is bigger or smaller, depending on the situation. Feel good so far? Okay. So you get you get your career, right? You have like your real job. What's the first thing you're doing once you start getting paid? First thing you do once you start getting paid. Get paid real salary. What is the first thing you're doing? Start saving for retirement. Yes, absolutely. First thing you want to do, start saving for your retirement. Typically, the way people do that is they pay the same amount out of every paycheck into some kind of retirement savings account, whether it's a 401k or IRA or all kinds of financial tools to start to do that effectively. That process where you taking like the same amount every month and paying it into some kind of account is called an ordinary annuity. So if you wanted to calculate the future value of that 401k or your retirement savings account or whatever, we'll call it just an annuity in general. You can do that using this formula. PMT is that monthly payment that remains the same over the terms of this annuity. The I is the interest rate over 100 times the number of compounds per year. The capital N is the number of payments. So it's the compounds per year times the number of years. So at the end of each quarter, Sarah makes a $500 payment into an annuity account. If her investment earns 7.88% annual interest compounded quarterly, what will the value of Sarah's annuity be in 20 years? What word in here tells us the formula to use? Not quarterly. Not annual. Annuity tells us that this is the formula we need to use. As soon as you see annuity, that's the formula. Again, I'm going to try to do some code breaking in terms of what you need to read in there to know which formula you use, because we're seeing a whole bunch of them so far.
We're going to have this test, right?
The formulas would be given to you. Never going to ask you to memorize a whole boatload of formulas. That's algebra rules, sure. Formulas to solve a story problem, no, this is too much. Even though by the end, when I show you how to do stuff on your calculator, you really won't need a formula to do most of these. But we're starting off with the formula. All right. $500, what is that? That's your payment. That's your PMT. The 7.88% is our R. Compounded quarterly, that's our K. The future value is what we're looking for, and the number of years is 20. So we'll start with calculating our I and our cap N. Everybody's okay there? So filling things in, future value equals 500 times 1 plus. That I is going to be some stinky decimal that I'm not going to copy in. I'm just going to write down the letter I. Since I wrote down the calculation to get it on the side, is everybody okay there? So to get this bugger into my calculator, here's what I'm going to do. I'm going to start by computing this I. So alpha y equals, enter 7.88 over 400. So that's the value for I. Now what I'm going to do is, instead of typing that number in every time where there's an I, I'm just going to press second and the negative sign. That'll call the ANS command, which is just whatever the last answer that my calculator outputted, or output, to make that past tense. It'll place that number in that spot. So that just allows me to write a few less numbers. So that tells me I would have $95,483.39. Again, and I rounded to 2 decimal places because we're talking about money. Everybody happy with what we did there? Easy enough. The other, or the last situation we'll consider is if we have a loan. So say you are going to borrow some money. In that case, the present value is just the amount that you had to borrow. And basically, this is the same idea as an annuity, but instead of like adding money to an account, you're taking money out of a debt, right? But the formula is really similar because you're just kind of doing the reverse of your annuity. All right. So our example reads, Maria buys a new car for $18,500. What are the monthly payments for a 4-year loan if she makes $2,000 down payment and the annual interest is 2.9%? What word from that story problem tells me the formula that I need to use? Loan. So the loan formula is this one. Everybody's good? Okay. So let's see. Monthly payments tells me that the K is 4. 4 years tells me the N is 4. The payment is what we're going to be solving for. The 2.9% is our R, but what is the present value? How much did we borrow? Great. The present value is going to be the cost of the vehicle minus the down payment. Remember that a down payment is the money that you walk into the car dealership with already in hand, like a check or a whatever, and you pay right up front. Everything else you have to borrow, so that is the money that you're going to owe the bank. So our equation is going to look like over here, let's calculate our I and our N. Everybody's okay there? So to solve this, again, let's do a graph and find the intersection, I guess. That seems doable there. Here's the little hitch, though. To get the I, what I'm going to do is this. So I'm going to type that into the main screen. This is my value for I, this kooky decimal right here. I do not want to copy that down a bunch of times into the y equals menu. So what I'm going to do is I'm going to ask the calculator to remember this number. To do that, I'm going to use the STO button right here above the on. And I'm going to store that into the letter I. So when I do that, every time I type the letter I now, the calculator is going to remember that that's just that number. So I can use that kind of like a constant. So let's type this in, 16,500. Clear that out of there. The payment is my X. 1 minus 1 plus I to the negative 48 all over I. So I go to my window. The X this time is representing the amount of money we have to pay for the car every month. So you're borrowing $16,500. You're going to pay it back over the course of 4 years. Obviously, 0 is a lower bound for a car payment. You're not going to pay negative monies ever. But what would you expect to be like, like a high end for a car payment for a $16,000 car that you're paying over the course of 4 years? Like, what's a decent upper bound? Like, I'd be shocked if it was more than this. $4,000? So you're telling me in the first year you're going to pay $48,000 to the bank and that's going to cover a $16,000 car? So do the same math. That's $12K in the first year. You're going to do that for 4 years. $500-$600 is probably decent, right? Like, that's probably a good upper bound somewhere in there. Let's do 500. I know you guys have never bought a car before, so it's like sometimes I'm just asking questions to like see what your head's at. But this is the hard part about doing this by graphing, right? So you have to be able to think about like, okay, give me like a range for a reasonable answer. It doesn't have to be like a crazy range. If you'd picked 4,000, it would have been fine. You just would have had like a squished up graph, but it'd probably be okay. What do the Y's have to be? The Y's are going to be the value or what you owe. All I really care is that they wrap around this 16,000 number. So I'm just going to do like 10K and 20K. Does that sound okay to you guys? Because that should be everything I need. So there's the 16,500 line. Here's my car payment. There's my intersection. So second trace, intersect command, enter, enter, enter. 364.49. Okay. Last question. Using the same information from the previous example, assuming all the payments are equal, how much interest does Maria pay over the life of her loan? So how many payments are we going to have to make? 16? Okay. Okay, 4, the number of years, times 12, the number of payments per year. And then how much are we paying each one of those 48 payments? $364.49. Yep. So let's figure out how much we've paid the bank then, right? Because that number, whatever that is what we're going to pay the bank. So $17,495.52. Yeah, what was that? $995? $495. Yes. And how much did we actually borrow from the bank originally?
16.
So what's the remainder here? That is your interest. So it cost you basically $1,000 to borrow the money to buy that car, right? All right. Take out your graphing calculator. Let me show you a fantastic tool that's built into your calculator. Because all of this like graph and find the intersection thing for these, your calculator is a tool built into this to deal with these financial situations that can just do it for you with no graph needed. Everybody ready? Locate the apps button. Apps is in purple. It's kind of near the green alpha button. Press the apps button. Which application do you suppose we want? There's only one choice. It's got to be finance, right? The one you're going to want to pick is the TVM solver. So here for the capital, let's say let's do example 39. So we're going to be solving for the payment. Okay. So for the capital N, we need the number of payments. So 4 times 12. The percent interest is just the general interest rate, that 2.9. The present value is 16,500. I'm going to just put a 0 there for payment for now. The future value is going to be 0, right? When this loan is done, we owe nothing now. It says we're going to be, the P/Y is payments per year. It says we're making 12 of those. And the C/Y is compounds per year. Going to be making 12 of those. We're always going to set the payment to happen at the end of the month. So now if I want to figure out what that payment is, I'm going to move my cursor so it's sitting there on PMT, and press alpha and enter. There's our 364.49. Why is it negative, Mr. Kulik? Because it's leaving your pocket, right? So there's always like a flow implied on this TVM solver. So if you start getting errors, oftentimes it's because you have like some sign disagreement going on. But this will do like any of these financial problems. Let's scroll back up and do like example 38. Absolutely. Yeah. If you write down what you did on the solver and give me the answer, that's fine. Yeah, for sure. If we do example 38, so here we know the payment, that's 500. The present value, well, we started with nothing in the account, right? So I'm just going to make that 0. The interest rate was 7.88. That's a pretty good investment. And our N was 4 times 20. And compounds per year, well, this was quarterly, right? So that should be 4 and 4. So I'm going to go to that future value now. That's what we're looking to solve, and press alpha enter. And there's my $95,483. And I never worry about the negative signs. It just, I know, like there's some directionality implied, but I don't really care. Like I know the money that I'm getting for all these questions seems to be a positive number. So like, whoop-de-doo-doo. Does that feel okay to you guys? That's a pretty cool tool, right? Super helpful. Potentially. It takes a little bit to get used to how to use it, but like that's the gist of it. You know, you just got to get used to like making sure you got stuff in the right spot and then just alpha enter for what piece you're looking to solve for. Everybody happy? All right. At this point, you guys should be able to finish 147 to 84. So that's going to be part of Sunday's problem set along with 131 to 146 or whatever that we already assigned. And then we'll have the review for chapter 15 as the last piece of that last chapter 15 problem set. You guys feel good? Any questions? Okay.